Hey, what's up? We're talking about functions today. So what is a function? A function is just a relationship where each x value is associated with only one y value. Okay, what that means, our x values can't repeat. Functions are, here's an input, it gives me an output. And what we're saying is that when I put one x in, it only can give me one y out. It can't, the same x can't give me multiple different y values. Each x can only have one y. X values cannot repeat. So where do we see functions? We see them in ordered pairs, tables, mappings, graphs, lots of different ways that you can see them. This is our focus for today. Okay, so we're going to start with ordered pairs. Remember, this is all about the x value. The brackets that you see, that just tells me that that's a set. So we have this set here, right? We have another set. So those aren't related to each other. It's just telling us, hey, these ordered pairs, what can you tell me about them? Okay, and what I can tell you is I'm looking for those x values, and they can't repeat because they can't have more than one y value associated with them. So I look here, negative 1, 0, 2, 4. No x repeats. That's why it's a function. If I look at the bottom one, again, it's just the x values. I don't care that y is repeating every single time. Y can do whatever it wants. It's all about x. 3, 2, 1, 0. No x repeats. That means every x has its own y. Okay, each x is associated with only, almost wrote the wrong thing there, only one y value, okay? But when we look at our non-functions on the right here, if I look at my first ordered pair, my first set of these, I can see negative 3 is with 0, but negative 3 is also with the 2. Negative 3 has 2 y values, and that's not allowed for it to be considered a function. It's a different kind of relationship, but it's not a function, okay? When we look at the second one, I see negative 2 repeats. It has negative 1 and 3. That's not allowed. Negative 2 has 2 y values. When I look at 0 as well, 0 has 2 y values. As soon as an x repeats, it is no longer a function, okay, because that means each x is associated with more than one y value, okay? So looking for those x, looking for the x's, okay? Let's look at tables. Same exact thing, guys. So I look at my x values to determine if it's a function. X cannot repeat. 2, negative 3, negative 8, negative 13. No x repeats. When I look at my horizontal table, I look at those x values, negative 2, negative 4, negative 6, negative 8. No x repeats. Every x has its own y, okay? Every x only has one y, okay? Only one y, only one y. That's the big key here. So when I went to look at our non-examples, in our vertical table, I see 5 is with 0, 5 is with negative 8. So 5 has 2 y values. And that's not allowed. Functions, each x has only one y value, okay? So when I look here, that horizontal one, man, negative 2 has all kinds of partners, okay? Negative 2 has multiple y values. Again, as soon as it repeats once, it's not a function. Okay? Each x value is associated with more than one y. It has to only have one y value. That's what makes it a function. X cannot repeat. All right, mappings. Mappings are a cool way to look at ordered pairs. Okay, the left side is x, the right side is y. Left side is x, right side is y. Left side x, right side y. Right, so I'm just going to label those so that I'm training my brain what to look for. And really, this is how you see the ordered pairs. The line connects the x and the y values. So this ordered pair, the 4 is connected to 8. So that ordered pair is 4, 8. The 5 is connected to 4. So 5, 4, okay? The 9 is connected to 4, so 9, 4. If I know that, I can look and see like no x repeats. But another way to see this in our mappings is every one of these only had one line coming from the x values, okay? That's a big clue with mappings that, oh, the x only has one y, because remember, the line connects it to the other value, okay? So when we look below, 2 has one line, 3 has one line, 4 has one line, 6 has one line. Each x has one line, which means it has one value, y value, okay? So each x is associated with only one y value. All right, when we look at our non-functions, if I look over here, I see 0 has those two lines coming to it. So that's 0, 0 and 0, 8. 0 has two y values. That's not allowed, right? So be very careful with that. But again, it had two lines coming off of it. So when I look at this bottom one, 3 is fine, 4 only has 4, but 6 is connected to 4 and 9, right? 6, 4, 6, 9. 6 has two y values. That's not a function anymore. That's a different relationship, okay? The x value is associated with more than one y. Okay, all right, and then our final representation here is our graphs, and we use what's called a vertical line test. I really wish I had a paper I could do this with you, but what I do is I take my pencil, right, and I should be able to slide the line all the way across, right? I should be able to take that line all the way across, and it should only ever hit my graph in one location, okay? If I were to draw this, it only hits my graph once everywhere. If I draw it here, okay, and you can do this when you have something, you can take your pencil and slide it across your graph, okay? It should only hit your graph in one location. That proves that the x values don't repeat. I'm going to write this. Vertical line only hits graph in one location. Anywhere on the graph, right? And that's to prove that it has only one. What this looks like with non-functions is if I draw that vertical line here, I'm hitting my graph in two spots. A vertical line, all the x values are the same. Look, if I were to write this ordered pair, it'd be -1, 2. If I draw it here, it's -1, -2. Uh-oh, look at those x values. -1 has two y values, and remember that disqualifies it. And so that's what that vertical line test tells me. It shows me, hey, these x values are stacked, you can't use them, right? If I were to use this line, okay, I can see right here both of those. So that would be like -2, 1.5 maybe, okay, and this would be -2, -1, okay, again, -2 has two y values. And I could see, sorry, my stylus is being a little wacky, that disproves it being a function. Okay, nothing can overlap. It can't stack on top of each other. Each x has more than one y value. Okay, and so that's how you can tell functions from ordered pairs, tables, mappings, and graphs. You're looking, x can only have one y. It has to be unique, okay? X can't have multiple y's associated with it. That makes it not a function.